Okay, so what I've got for you today is a demo of the auto enrollment for Actuated. This allows you to auto scale machines, add and remove them whenever you like, completely on a self-service hands-off basis. We're going to have a look at the new docs. Here you can see the new instructions. It's very, very simple, and this can be pasted into user data, Cloud Init. It can be run via Terraform, Ansible, or just manually over SSH, which I think is quite a good way of doing things. Now, first of all, we're going to create a droplet on DigitalOcean. Why use DigitalOcean? Mainly because it has nested virtualization, and it's a cheap place for me to show you a quick demo. This is not where I would suggest you run your CI. There are much better, cheaper options available, but it's going to allow us just to add a volume that can be used, and it has user data. So, you use wherever you need to use. What I've got here is the script populated with the license key. This just happens to be a static one, valid for 1 day. We've got a token that I will rotate before I upload this. I've also added a label of DO so that we can immediately task this specific node with one of our jobs on GitHub Actions. And then over here, we'll call this DO London 1 EMD1. Name isn't that important. Once it's been created, we will get a public IP address for it, and we can go have a bit of a snoop, look at the logs. So this should be available in a second. Generally, DO VMs pretty fast at booting up. Here we are. Volume might have just made it marginally slower. There we are, we're in. Okay, so what we can do is if we open up the journal, we can just follow along with the normal Cloud Init. We can't really do a lot about DigitalOcean running its own Cloud Init on startup. It puts its own software on there. But then as soon as it's done that, it's going to put our software on, running our user data. So you can already see some updates being run, and then we're going to see packages being installed. So whilst that's running in the background, how does this differ to what we had before? Well, in the past, it was very similar. So you would create your license after logging into the machine. You would download the agent, which had the installer script in it, and then decide if you wanted dev mapper, ZFS, etc. Run the installation. That would configure any snapshots for storage. You would then run the enroll command, which would generate a YAML file that you would share with us via email or Slack with encrypted secrets within it. And finally, you would install a service and specify a domain. You'd have to create a subdomain for each runner, and then you could check that it's fully up and running and start using it as soon as we'd added it on our side. Now that the addition of the machine is completely automated, you don't even really have to think about the storage, because the script will try and guess the best place to put the VMs, and if it can't find a good place, it will just create a loopback file. It will assume that you're in like testing and development mode. The Docker username and password can be given, and when you give those, it will use, let's say, an anonymous Docker Hub pull token that you've created to perform pulls through the internet whilst caching on disk. So the first pull of Ubuntu latest might be quite slow. The second pull would be instant. We talked about labels, and I guess the other thing to say is if you leave these blank, you will still get a pull through cache, but you'll be using the anonymous pulls instead. So we're getting there. It seems like we've written out the actuated service. That's the end of the installation script, just confirming where it put the storage. And we should now see Actuated starting up, and we might be able to switch over to following its direct service in systemd instead. Yep. Now the unpacking, so the pulling of our root file system image took 7 seconds because it's on the fast internet. But because this is a slow VM, it's not bare metal, it's not a fast VM, unpacking this could take like just over a minute, maybe up to 100 seconds. On my machine that I've got here, my Ryzen desktop, probably takes 20 seconds. So 61 is actually quite fast. And now this is immediately ready to run jobs. Going over to the Actuated dashboard, we can now see under runners that's been added. So this is the customer name, and then it's got the host name from the machine. And we know that has a label of DO. So the next thing to do would be to go to a GitHub action. We see this already says runs on Actuated, and into that we could put something like the second label DO. When I hit commit on this, it will actually run on the machine we just started up, and you'll see the VM boot on here, and that's it. Like, we're literally running, and we can tail the logs from that. We see it's connected to GitHub. GitHub's tasking it with the job. Sometimes it takes a second or so, a few seconds for Git to actually give it to you. In this case, that was pretty fast, about 1.8 seconds, and GitHub gave us a job. The VM is now completely deleted. It's no longer on that machine. So if we look for Firecracker processes, there are none. Completely ephemeral. The action completed successfully, and now there are no longer any jobs running on that host. So if you want to see it again, rerun it. We'll see as soon as GitHub gives us the webhook, it shows us queued. Over on our runners, we see the VM is launched. Over on our console, we'd be able to tail the new logs. VM's booted up, and it's running, and it takes about 5 seconds. So we know that so 8 seconds, so we've got about 3 left. Refresh it. It's taking a teeny bit longer this time, and it's gone. All done. That's how easy it is to add them. Now, if I go on this droplet and I destroy it, within a short period of time, it will drop off our account, and we're back to where we were again. We've got all of our permanent runners that have been set up previously. As you can see on here, we maintain 2 active ones, and then we have a few that we use for testing. So that is the experience. That is how easy it is to add a new runner. So whether you're using a bare metal machine on Hetzner and you copy and paste that block in over an SSH session, whether you've configured it through Terraform on Google Compute Engine or on Azure, any cloud that has nested virtualization, you can have an agent fully set up in a couple of minutes, and you can even automate it and auto scale it.